Jai Hind viewers, I am Sudhakar Dwivedi, Assistant Professor in Information Technology Department at Kumar Engineering College, Ghaziabad. Today, I will discuss about a very important topic in Python programming that is known as Numpy, stands for numerical Python. So, Numpy, as I have said, it is stands for numerical Python, and it is used for manipulation of large data sets. So what is actually Numpy? So Numpy is a Python package and it stands for numerical Python, and it's a library consisting of multi-dimensional array objects and a collection of various routines and methods for processing of large data sets as an array. Examples, as example, we can take an data like the sound data, image data, and all data that have large amount of data sets, but Numpy can also be used anywhere we have large data sets to process and manipulation. As a part of attraction of Numpy, why the Numpy is so much popular for processing the data sets? Because it uses a simple and the familiar Python syntaxes to perform the complex operations on the arrays that simplifies the operations on the large data sets. And the other benefits is that the Numpy is highly efficient, both in terms of the speed and the memory uses. So we basically use the Numpy because it is efficient in terms of the memory uses, and it also performs the operations on the arrays very efficiently. So the Numpy arrays is basically used to perform the manipulations on the large data sets. So Numpy is actually an open source multi-dimensional or mathematical and scientific computing library for Python programming tasks. The name Numpy is shortened for the numerical Python, as I have said, and the Numpy library offers a collection of the high-level mathematical functions, including the support for multi-dimensional arrays, masked arrays, and the matrices. Numpy numerical Python is also includes the various logical and mathematical capabilities for those arrays such as the shape manipulation, sorting, selection, for the linear algebra manipulation, statistical operations, random number generations, and discrete Fourier transformations. That means this module can be used to perform a complex manipulations and calculations on the large data sets. What is the common applications of the Numpy, where we can use the Numpy actually? So we can say, see here, the Numpy can be used for the large data sets and or for performing the manipulation or calculations on the large data sets. So Numpy is a mathematical library and can be used to integrate the complex numerical computing functions into Python code base actually. So Numpy is also routinely used in many different data sciences, machine learning, concepts, and scientific Python software packages, including all of these. We can use the numerical Python in the matplotlib, in the Python pandas, in the scikit images, scikit-learn, and the SciPy for the scientific calculations. And where we use a Numpy, as we are discussing, using the Numpy, a developer can perform the following operations. We can perform the mathematical and logical operations on the arrays. We can perform the operations on the Fourier series, that means Fourier transformations and routines for the shape manipulations. Operations related to the linear algebra. Numpy has an built-in functions for linear algebra and the random number generations. We can say that these Numpy packages or the libraries can be used to perform the complex logic on the large data sets. Is a Numpy a replacement for the MATLAB? Yes, Numpy is often used along with the packages like the SciPy, as I have said, for the scientific computations, and Matplotlib for plotting the libraries, for the plotting the graphs for the libraries. This combination is widely used as a replacement for the MATLAB actually. And this combination is widely used as a replacement for the MATLAB, as I have said. A popular platform, MATLAB is a popular platform for the technical computation. But here we are using the Numpy. However, the Python alternative to the MATLAB is now seen as a more modern. Why? because it can have a complete programming, it can have a complete package for performing the manipulations and the calculations on the large data sets. And it is also open source that make it more popular, which is an added advantage of the Numpy. So Numpy has an added advantage because it's as an open source. So how we can use this Numpy environment? So the Numpy environment is not coming with the standard distribution. So standard Python distribution does not come bundled with the Numpy module. A lightweight alternative of this Numpy module can be downloaded and installed in our systems. So we can use the pip install commands for this to install the Numpy module. And the best way is to install the binary package specific to our operating system. After installation, we can use this Numpy for our tasks. So Numpy is actually a key library for handling a large numerical data sets in the Python. And it is often used for calculation and manipulations in the large data sets. It is often used as the interface between the other data science libraries, as I have said, that we can use these Numpy with the pandas, matplotlibs, and scipy. So first, if we want to use the Numpy, we have to install the Numpy in our system, and then we must have to import this Numpy. So first we import the Numpy package. We will see in the implementation part later. So if we want to use this Numpy for our programming tasks, first we have to install it, as I have said, in our systems, and then we have to import this Numpy package. It is a common practice to import the Numpy as NP. So we can import this Numpy package, this Numpy library or into our system in our programs for the further computation. So this is the syntax to import the Numpy. So we have written the import, then this Numpy, and we are importing this Numpy as an NP. So this is the common practice or the common way to import the Numpy for the further processing in our programs. So Numpy is actually used to create the ND array objects. So why we use Numpy? So Numpy is actually, we can say, the collection of the n-dimensional array objects, or we can use the Numpy is to create the n-dimensional array objects. So the most important object defined in the Numpy is the n-dimensional array type called the ND array, and it is described the collection of items of the same types. So what is the array? What is the n-dimensional array? So array is basically a collection of homogeneous or similar type of the data elements. That means the Numpy is a collection of the items of the similar types or the homogeneous types. So items in the collections can be accessed using the zero-base index. So because it is an array and it is a number of elements, we can access each elements by the index specified. So every item in the ND array takes the same size of the blocks in the memory because the items are of the same types, and each element in the ND array is an object of data type object called D type. So any item is extracted from the ND array object by slicing or indexing. So if we want to access the individual item in the array, we can access the ND array elements by using the ND array indexing or by slicing. We will discuss in the implementation part later. That means once we have created an ND array objects, we can access each elements or the whole array by using the slicing or the indexing. So how we can create these ND array objects? So if we want to create this Numpy array objects in our programming for the purpose of data processing, as I have said, first we have to install this ND array library into our system, and then we have to import. First we have to import this Numpy. And if we want to create, we have a various routines, we have a various functions to create this Numpy array into our programmings. First, we can use the Numpy array function. This array function we can use to create an ND array objects. So this we can use the numpy array function to create an array by passing a Python list or tuples as an argument to the function. That means we can pass the list or tuples to this array function to create a ND array objects. And this function converts the input data, like we have passed the lists or tuples, into an ND array or numpy array objects. The basic syntax of this array function is, so basic syntax of this ND array function is, this is the function array. The first parameter is object. Objects is any data like the lists or tuples. We can pass the data types and the default is none. This another parameter copy and the default value was copy is true. We will discuss later about this. Order. What will the order? The default value is k. This parameter, the default value is false, and this NDMIN value is 0, and like parameter, the default value is none. But here we will focus on few parameters, and these parameters are shape, dtype, and order for the creation of the ND array objects. So as I have said, to create the ND array objects, it can have the various parameters. So these are the values of the order parameters. So value C, as I have said, the value C, F, A, and K. So C, we provide the C in the order parameter as a value. That means it's a contiguous layout, and mathematically speaking, it's a row measure order. If we provide the value, provide the value F, that means is a Fortran contiguous layout, and mathematically we said a column measure. So basically we will use the row measure or column measure order for creating the NumPy arrays. It can also have the value A and K also, but it is not recommended to use. As I have said, we have a lot of routines provided with the NumPy to create the NumPy ND array objects. And first we have discussed about the array function. Through array function, we can create these ND array objects. Another routine here, if we want to create an empty array, we can also use this function, empty function, to create an empty array. That means to create an uninitialized array. So a new ND array object can be constructed by any of the following routines that we will discuss later in the subsequent sections. So first one is we have discussed the ND array functions through which we can create the ND array objects. Now it's a NumPy empty function. And it creates, the NumPy empty function creates an uninitialized array of specified shape. That means in the this function, we can provide the shape as a parameter. We can also provide the dtype for specifying the data type. And as I have said, we can also provide the order parameter. So this empty function can have the various parameters for creating the empty ND array objects. So the constructor takes the following parameters. These are the parameters. The shape parameter, shape of empty array in integer or tuple of integer. So we provide the shape in integer or tuple of integer. And dtype, it is optional. And if we want to specify a particular data types, we can provide the dtype parameters also. And order. As I have said, we can also provide the order parameter, and we can specify the orders. We can either provide the row measure order. We have to provide the value C. And if we want to provide a column measure order, we have to provide the value F in the order parameter. And see the codes. So as I have said, first we have to import the NumPy. So we have import the NumPy package or NumPy library as NP. Now we have used the empty function to create this empty array. So we use np.empty and we have provided here the shape of the array we want to create, and this is the data type, and this is the data type of integer of 64 bits. So the point to note here is that the element in the array show the random values because the elements are not initialized. This is the empty array. So the element here is not initialized. That's why it will take the random values as they are not initialized here. So as they are not initialized here, it can take or it will take the random values. Another function to create the ND array object is NumPy zeros. The parameter is same parameters, dtype parameters and order parameters. The zeros function is used to return a new array of a specified size filled with the zeros. That means if we want to create an ND array objects that are all filled with the zeros, we can use the NumPy zero function. Here we can look a code. So here we have used the zero function and we have provide this number. That means it will create an array. It will create an array and filled with the zeros. We will look in the implementation part and see here. This is the another function and we have provided the shape here. That means 2 rows and 2 columns, and d types for the here. It's an integer of 4 bytes, integer of 4 bytes, and this is the output. This one. Another function, as I have said, the NumPy zeros are used to create an array that all filled with the zeros. Another function is NumPy ones. That means if we want to create an ND array object that all are filled with the ones, we can use the function NumPy ones. The parameter is the same, and as we have, as we can see here, we have used the the NumPy ones. So first we have to import, as I have said, as a NP. Then we have called the NP ones function here, and we have passed a number 5 here. That means it will create a NumPy array filled with the 5 ones, 1, 2, 3, 4, 5. And we can see here the default data type is float here, 1 dot 1 dot. That means it's a float data types. If we want to change the data types, we can provide the data type here as a parameter. We can provide the data type here as a np dot integer 64. So here we have created the NumPy. Here we have created the NumPy array objects by using the np1s functions, and we have provided first the shape here. Shape means 2 rows and 2 columns. We can see here. This is the 2-dimensional array. This is the 2-dimensional array. That means this type. This is the 2-dimensional array. It's the 2 rows and 2 columns. So we have provided the shape. It's a 2 rows and 2 columns, and all are filled with the ones. All are filled with the ones. So we can use the np or NumPy ones function to create an ND array objects all filled with the ones. If we have not provided the data types, it will create a float data types by default. And if we want to change the data type as per our requirement, we can provide the data type in the dtype parameters as specified in this example. Another routine is NumPy as array. As I have said, we can change the data type of our requirement by providing the data type parameters. And sometimes in the we are not able to change the data types. For example, if we want to create an array, for example, take this Numpy array, and we have some elements here, like we have an element like 1, 2, and now A here. And now we want to change the data types. And here we can see that it's integer types, and it's integer type, and it's a string. And if we want to change this data type in a particular data type, it may create some mismatch, because we cannot convert this to float or integer. So we can use another function, we can use another routine for converting this type to another type. So the as array function is also similar to Numpy array, except for the fact that it has some few parameters. So the Numpy as array function, we have to provide input data in any form, such as list of tuples, tuples of tuples, or tuples of list. That means first we can provide a data, then D type parameters, and then order parameters, as we have created the arrays in previous examples. So Numpy array from existing data. If we want to create an array from the existing data, we can use the as array function. Here we have created a list, as we can see here. Now we want to create an array from this list. So we can use the as array function here, and we pass this list as a parameter to create the ND array objects. So we have created a list first, and then we have passed this list to the as array method. And then we have created the ND array objects. Another routine to create the ND array objects is a range. This is a range. So this function returns the ND array objects containing the evenly spaced values within a given range. That means by this function, we can provide a range, and it can create the ND array objects evenly spaced by the evenly spaced values within the specified range. And the specific format or the to create this ND array object is Numpy arange function. And as a parameter, we can provide the start, from where we have to create this ND array objects, then stop, and then steps. And as I have said, if we want to create an array for the specific data types, we can also provide the D type parameters. These are all the this constructor can take the following parameters, as I have said: start of an interval. And if we have not provided this start index, the default of this is 0. End parameters, that means the end of an interval, and this end interval is not included in this range actually. And the step means spacing between the values. If we have not provided this step parameters, the default step is 1. And data type of resulting ND array, if not given, the data type of input is used. If we want to create an ND array object of specific data types, we can use the D type parameters. For example, see, we have created an array ND array objects starting from 0 actually. We have provided only one parameter here. As I have said, the array function, the arange function, as I have said, arange function can take 3 parameters. The parameter is, basically the parameter is, see, the parameter is start, stop, and step. This is the basic parameter. And here we have provided only one parameters. Here we have provided only one parameters. So as I have said, if we have not provided the start, so by default it will start from 0. And if we have not provided the step is 1. The step is positive 1. And I have said the stop or end, start or beginning. So stop or end is not included. So 5 means it will generate the numbers from 0 to 4 because the 5 will not be included. So it will generate numbers and it will create an array. It will create an array starting from 0 to 4 because the 5 will not be included here. Another example here. Here we have provided the starting index is 10 or beginning is 10, end is 20, and step is 2. So it will generate a number starting from 10. It will generate a number starting from 10. But 20 will not be included and step is 2. Now the interval is 2. So it is 10, then 12, then 14, and then 16 and 18, and 20 will not be included. So 20 will not be included, so it will create an array starting from 10 to 18. This is another routine to create an array object, and this function is similar to arange function. This function is also similar to the arange function, and it is also used to create the array objects of the evenly spaced data. In this function, instead of the step size, the number of the evenly spaced values, between the interval is specified. So what is the basic format? We use this function start, stop, and we have provided the number, we have provided the endpoints, then we have to provide the RET step, return step, and then D type. So start is the start value of the sequence, stop is the end value of the sequence, and what is the num parameter? The number of the evenly spaced samples to be generated. How much evenly spaced samples we have to be generated, we have to provide it in num parameters, and the default value is 50 for this. Endpoints, the default value is true, hence the stop value is included. That means if we provided the value, if we do not want to include this value, we have to provide the value as a false. That means if we have to provide the value as a false, it is not included. So endpoint parameters default value is true. That means this value will be included. And if we do not want to include this endpoint value, we have to provide the value as a false. What is the RET step? Means return step. And if it is true, it returns the samples and steps between the consecutive numbers. If it is true, if we have provided the value true to these parameters, it will return the samples and step between the consecutive numbers. And data type parameters is the data type for the array objects. This is the code. We have created an array 1 here. This is the num parameters. That means we want to create a 10 numbers. We want to create a 10 evenly spaced numbers from 0 to 5. This means we want to create an array of 10 evenly spaced values from 0 to 5 here. Now, if we want to create an array with the 5 values from 1 to 2, excluding the endpoints, we do not want to include this 2. So here the value starting from 1 to 2. We want to create a values from 1 to 2. And we have provided the value 5 to the num parameters. That means we want to create the 5 evenly spaced values from 1 to 2, but we do not want to include this 2. So we have to provide the endpoint parameters as a false. Creating an array and returning the step values. If we want to create an array and we want to return the step values, as I have said, we have to provide the parameters ret step as a true. So for today's, that's it, and we will see in the implementation part, the implementation specific codes of these routines and the functions. Thank you so much.